What's good, math family? Today we're looking at radical equations with fractional exponents. We're going to touch on how to solve these type of equations as well as when to use absolute value to help find the solution. So in the first example, I just want you guys to understand that we could rewrite this as a radical equation, a cube root radical equation, and solve. It's going to be the same steps. But if we stay in radical form, first thing we're going to want to do is just add 5 to both sides. Same steps. So we have 2x plus 1 to the 1/3 is now equal to 5. So remember that this is a fraction, and if we want to cancel out our powers, we're just going to multiply by the reciprocal. So I'll put this in parentheses, multiply by 3 over 1, and what happens is we're going to get a fraction of 3 over 3 for our power, which simplifies to 1. So this is the same thing as just canceling out the exponent. Now we do that to the other side, and 5 to the third power is just 125. And now we could solve like a regular equation. We subtract 1 on both sides. We're left with 2x is equal to 124. And then after we divide, we know that x is going to be equal to 62. So just like any other type of equation, we need to make sure that we plug this back in to determine if this is an extraneous solution. So once we do this, this is what we should have on the screen. So we know that when we simplify what's in the parentheses, we're going to get 125. We know if we take that to the 1/3 power, that's just the same thing as taking its cube root, which is 5. And after we simplify, we notice that this is going to be a true solution, meaning that x is equal to 62. In the next example, we notice that we have a fraction that's being taken to the 1/3 power. But family, our first step is still going to be the same. We need to isolate that term with the rational exponent. So after we add 10, we're going to have x over 4 to the 1/3 is equal to 12. So now at this step, we're going to try to get rid of that rational exponent by multiplying by its reciprocal, 3 over 1. We're going to take 12 to the third power as well. So these two cancel out, our exponents cancel out. We're left with x over 4 is equal to the cube root of 12, which should be 1,728. Now remember, we're trying to solve for x, so what we want to do now is just multiply by 4. To get rid of the fraction, do the same thing on the other side. So now we have x is equal to 1,728 times 4. That's going to give us 6,912. So when we look at our answer for this one, we know that 6,912 is going to be our answer. If we plug it in and we do 6,912 divided by 4, we're going to get 1,728. When we take that cube root of that, we'll get 12. 12 minus 10 is equal to 2. True solution. So this example is a very special case. And the reason why is because this is when we're going to use absolute value to solve the radical equation. We use absolute value when we have a even root, and after we simplify that even root, we get an odd power. And I'm going to explain that. So right now, as we look at this, we see 2 over 3. Yes, the root is odd. But let's just go further so I can show you why we have to use that absolute value concept. So after we isolate, we're going to have x plus 1 to the 2 over 3 power is equal to 4. So like the previous problems, we have to get rid of our rational exponent. So to do that, we're going to multiply by the reciprocal, which is 3 over 2, right? Apply that to the other side. So now we're left with x plus 1 is equal to 4 to the 3 over 2 power. Now at this instance, we have a even index, even root. So if we simplify this and get an answer to an odd power, we have to use absolute value. So what does this mean? Well, think about this. There's two ways to break this down. We could do 4 to the third power, then take its square root, or we could take the square root of 4 and then cube it. If we look at the first instance, this is going to give me 4 to the third is 64. The square root of 64 is equal to 8. If we do it the other way, the square root of 4 is 2. 2 to the third power is 8. But if you look, we have a power of 1. So even index simplified to an odd power. So this is when we're going to use this concept. So now with this step, family, we have x plus 1 is equal to 8. So now this is when we create the absolute value. We have the absolute value of x plus 1 is equal to 8, and we have the absolute value of x plus 1 is equal to -8. So now when we simplify, right, we drop the brackets, x plus 1 is equal to 8. So we know our first answer, x is equal to 7. And in our second answer, after we drop the brackets, we know that x is going to be equal to -9. And the reason why this occurs is because when we square a negative number, we could also get a positive answer. This is really the main reason. So let's go through and let's actually check this now. So let's check our positive answer. So we have 3 times 7 plus 1 to the 2 over third power is equal to 12. So we have 3 times 8 to the 2 over third power is equal to 12. We already kind of simplified this, so we know what? 8 squared is 64. The cube root of 64 is just 4. So when we simplify, this turns into 3 times 4, which equals 12. We know that this is a solution to the radical equation. Now let's say if I switch colors and I go to green, and now we substitute in -9. So we have 3 times -9 plus 1 to the 2 over 3 power is equal to 12. So now remember this. After we combine, we're going to get -8 to the 2 over 3 power is equal to 12. So think about it. -8 squared is positive 64. The cube root of 64, like we said before, is just 4. So once we simplify, we're going to get 12 is equal to 12. So be mindful when you have an even root and you simplify and now the power is odd. This is when you're going to use this. This is when you're going to use this concept. And now we're going to go on to the next problem. In the next example, we notice that our index is odd. So we don't have to worry about this, or the concept of absolute value, I should say. So we're going to subtract 1 as our first step. We're left with 2 times 2x to the 1 over third power is equal to 4. So we go ahead and divide by 2. 2x to the 1/3 power is equal to 2. Now we're going to use our reciprocal power to cancel out that rational exponent. 3 over 1. Take the other side to the third power as well. So now we have 2x is equal to 8. And once we simplify by dividing, we know x is going to be equal to 4. Now let's say we plug this back in. 2 times 4 gives me 8. The cube root of 8 is just 2. So 2 times 2 is 4. Plus 1 does equal 5. So we know that when x is equal to 4, this is a solution for the radical equation. In this example, we notice that our index is odd. So we don't have to worry about the absolute value concept like we do with the even root. So after we subtract 1, we're left with 3 times x plus 1 to the 3/5 power is equal to 24. We notice that the rational exponent is not by itself, so we're going to divide by 3. So we have x plus 1 to the 3/5 power is equal to 8. So now at this step, it's the rational exponents by itself. So now let's take its reciprocal to cancel it out. 5/3. We do the same thing to the other side. And just remember, we have a power and a root. This is not like the other examples where we're just taking 8 to the 3rd power. So just be mindful of that, because sometimes that mistake can happen if you're moving too fast. So we have x plus 1 since our exponents cancel out, and this is equal to, and then when we break this down, we know that the cube root of 8 is 2, and 2 to the 5th power is going to give us an answer of 32. So once we subtract 1, we know our final answer is x is equal to 31. Now, if we plug this back in, 31 plus 1 is 32. We know the 5th root of 32 is just 2, right? If we take 2 to the 3rd power, that's 8. 8 times 3 gives us 24. And when we add that plus 1, 25 is going to be our answer. So we know that this is the correct answer and it will satisfy the radical equation. Last problem of this video, and if you found it helpful, math family, please just smash the like button for us. So with this problem, we notice that we're not adding or subtracting anything. So we don't need to combine anything with 16. However, we need to divide so that we could isolate that expression. So we have x minus 2 to the 2/3 power is equal to 4, right? So now to get rid of our exponents, or cancel them out, I should say, we're going to multiply the reciprocal, which is 3/2. At this step, eyebrows should be raising because we have an even index. So let's see if when we simplify, do we get an answer to an odd power? So when we continue the problem now, we're left with x minus 2 is equal to 8. Because we know the square root of 4 is 2. 2 to the 3rd power is 8. So now at this step, this is when we create our absolute value equations. We have the absolute value of x minus 2 is equal to positive 8. And we have the absolute value of x minus 2 is equal to negative 8. So when I drop the brackets now and we solve, we know after we add 2, x is going to be equal to 10. And then in the second expression, once we drop the brackets and solve, we know that x is going to be equal to negative 6. So now at this step, we're going to plug this back in and see, are any of these extraneous solutions? So we plug in our positive answer first. So we have 4 times 10 minus 2 to the 2/3 power is equal to 16. So we know that this is 4 times 8 to the 2/3 is equal to 16. So we know the cube root of 8 is 2. 2 squared gives us 4. So essentially this turns into 4 times 4 is equal to 16. And once we simplify one step further, we know that this is a true statement. 16 is equal to 16. Now with our negative expression, once we plug this back in, this should be our first step. So we combine what's in the parentheses. So we have 4 times negative 8 to the 2/3 power is equal to 16. Now the cube root of negative 8 is negative 2. But when we then square negative 2, we're going to get a positive 4. So this turns into 4 times 4 is equal to 16. And like our previous answer, we're going to get 16 is equal to 16. So both of these answers are solutions to the radical equation. We really hope this lesson on when to use absolute value to solve radical equations was helpful for you, family. Smash the like button for us, subscribe to the channel, and if you had comments or questions, if you had questions on this video, just comment down below, or if there's topics you guys would like to see in our video in the future, just let us know by commenting on this video below. Thank you guys so much for watching Algebra 1 with Mr. Peters.